right, so in this video, let's look at just the length of an arc. Okay, so if we look at this arc right here, this is minor arc GK, and we have a central angle here, GNK, and so that we know that the measure of GK is going to be equal to the measure of angle GNK, because the measure of a central angle is equal, the degree measure of a central angle is equal to the degree measure of the minor arc that is intercepted by the central angle, okay? We know that an arc is a fraction of a circle. The whole circle is here. The arc is just a piece of it. So this is a fraction of the whole circle, okay? And so that means that the length of an arc must be a fraction of the length of the whole circle. And we know that the length of a whole circle is the circumference 2 pi r. And that means that the length of an arc is going to be equal to some fraction times the circumference, 2 pi r. So we need to find out, well, what is the fraction going to be? Okay? Well, we know that an entire circle, a whole circle, is measured in degrees. We know that a whole circle is 360 degrees. So we can put on the bottom here 360 degrees. So the arc itself is a portion of 360 degrees. And we know that the arc is also measured in degrees, that there is a degree measure of this arc right here, okay? And that is the measure of arc GK. And we know that it's equal to the measure of the central angle. And so we can say that the measure of this arc right here is the portion that we're trying to measure. The length from here over to here is a portion of the length of the entire circle. What portion? This portion, the arc itself, the measure of the arc. And so the formula for the length of an arc is going to be the measure of the arc, divided by 360 times the circumference 2 pi r. All right, let's write this a little bit bigger. All right, so here's our formula. You want to write this formula down, okay? The length of an arc is equal to the degree measure of the arc divided by 360 times 2 pi r. So this is the fraction and this is the circle. So the length of the arc is a fraction of the circle, okay? So here's what we need. In order to be able to do this formula, we need two things. We need the radius of the circle and we need the measure of the arc. So let's say that this circle right here, let's say that the radius was equal to 7, okay? And let's say that the measure of this angle right here, let's say the measure of that angle is 65 degrees, okay? Well, if this angle is 65 degrees and it's a central angle, then that means that the degree measure of the arc is also 65 degrees. So we can put 65 in here for the measure of the arc. The radius is 7, so we can put a 7 here for radius. So what is the length of this arc right here, this purple arc that runs from here to here? How long is it? Okay, well, the length is going to be, let's do our fraction. It's going to be 65 degrees in the numerator divided by 360 degrees times 2 times pi times the radius, which is 7. So we're going to need a calculator for this. All right, so here's our calculator. And we're going to do 65 divided by 360, and we'll close parenthesis there, times 2 times pi times the radius of 7, okay? And if we hit execute, we can see that the answer is going to be 7.941. This 2 is not going to change this 1, so we're going to cut off right here, 7.941. This is going to equal 7.941. And that is the length of just this. All right, let's look at this now. This is now asking what is the length of major arc GHK. Now that is this arc right here. And so now what we need is, we're going to need the measure of this arc. We need the degree measure of GHK. How many degrees is it from here all the way around to here? Okay. Well, we know that the degree measure from here to here is 65. And we know that the degree measure around the whole circle is 360 degrees, right? So if we want to know the measure of just this part that starts here and ends over here and is on the long side, we can do the whole circle, 360 degrees, minus the minor arc, 65 degrees. And that's going to give us 295 degrees. So the measure of arc GHK, the major arc GHK, is 295 degrees. And so the length of this major arc here is going to be 295 degrees divided by 360 degrees times 2 times pi times the radius, which is still 7. And we're going to go to our calculator to do that. So we're going to do 295 divided by 360, close, times 2 times pi times 7, and that's going to give us 36.041. 36.041, okay? And that is the length of this red arc right here. Now, if we want to know the circumference all the way around, we could add 36.041 to our previous length here, which was, I think, 7.941 or something like that, okay? Or to find the circumference, you could just plug 7 in here, and it's 2 times 7, 14 times pi, okay? Let's do one more example using an inscribed angle. All right, now look what we have here. We have this angle GHJ, okay? This is an inscribed angle. We reviewed those in the last video. And let's suppose that the measure of angle GHJ, let's say that the measure of that is, I don't know, how about 13 degrees? And we want to know, well, what is the length of minor arc GJ? That's this arc right here. We want to know how long it is, okay? It's the same circle we've been dealing with, so it still has a radius of 7, okay? And so the length of this is going to be equal to the measure, the degree measure of GJ divided by 360. Okay, so we know it's going to be over 360. Well, what is the degree measure of this arc? Well, we know that this angle right here is 13 degrees. And we know that an inscribed angle is half of the arc that it intercepts. Or we can say that the arc is double the inscribed angle. Well, if this is a 13-degree angle, then that means that GJ, minor arc GJ, is 26 degrees. That's 2 times 13. So we're going to put 26 degrees in our formula. And then we're going to multiply by 2 times pi times the radius, which is 7. And now we're just going to go over to our calculator again. And so we're going to do 26 divided by 360. And we're going to multiply by 2 times pi times the radius of 7. And that's going to give us 3.176. So this is going to be 3.176, okay? And so this is an example of doing the length of an arc when you have an inscribed angle. I recommend looking over this video a couple times if you need it while you're working through some problems. And what we're going to do in the next video is we're going to finish up with identifying the area of a sector.